Fuel oil system, heavy fuel oil. Fire. There will always be a certain danger of fire when running a diesel engine. A combination of leaking fuel oil and hot engine parts may start a fire that can be very damaging to the engine and in some cases dangerous to the engine crew. Leakages in the high-pressure part of the fuel system may create situations where the probability of a fire increases. It is of utmost importance to undertake inspections of these parts and carry out preventative measures against this on a regular basis. Thermal hazards. Fuel oil pipes may be very hot and should not be touched, even though they are insulated. Be aware that fuel oil pipes leading from the heavy fuel oil feeder, booster module to the engine may be steam traced. When performing maintenance on the fuel oil system, remember that heavy fuel oil is very hot. Fuel oils are flammable and should be treated with care. They may also irritate skin, so rinse off fuel oil as soon as possible. Take note not to wear clothing that is soaked with oil. All Ulsteinbergen main and auxiliary engines can be operated on heavy fuel oil under certain conditions, which include heavy fuel oil and lubricating oil quality, and the equipment which is needed. A safety and indicator valve is fitted outside the cylinder head. By means of this valve, the maximum pressure in each cylinder should be measured once a month. The measuring must be carried out with 100% load on the engine. Log the maximum combustion pressures and exhaust temperatures. Find causes and rectify if combustion pressure in one cylinder differs more than 3 bar from the average maximum at full load. Abnormal change in the exhaust temperature of one cylinder is indicated. Click the components for further information. The feeder booster module feeds heavy fuel oil to the engines. The module consists of equipment ensuring that the fuel oil is correctly filtered and that it will have the correct temperature and viscosity when entering the engine. The feeder booster module consists of the following main components: 2 suction strainers, 2 feeder pumps of which one is a standby pump, mixing pipe, de-aeration vessel, 2 booster pumps, of which one is a standby pump, 2 fuel heaters, automatic filter with separate manual bypass filter, viscosity control system, duplex fine filter. The oil temperature and oil pressure on the fuel oil outlet should be recorded every day. The changeover valve is equipped with a switch for heavy fuel or diesel oil operation. A light indicates if the engine is running on marine diesel oil or heavy fuel oil. Oil in the disconnected fuel oil system can circulate through the valve and is thereby kept heated to correct temperature. The cock enables switching between the filter elements, enabling replacement while the engine is in operation. In addition to logging the fuel oil pressure after the filter elements have to be checked at least once a month. How often they have to be replaced depends on the fuel oil quality. Make sure that the filter that is going to be dismantled is not in operation by checking the cock position. Open the vent plug. Empty the filter housing of diesel oil by unscrewing the plug. This is not necessary for checking the element. Unscrew the nuts and remove the cover. Remove the filter element from the housing and check the element. Wash out all oil sediments in the filter housing. Blow the housing clean with compressed air. Place the text in the correct sequence. Wrong. You have no more tries. We will show you the answer. Put the new filter element into the filter housing. Fit the cover with the nuts. Vent the filter by turning the vent plug 1 revolution until pure oil flows out of the drain pipe connected to the nipple. Further venting is done by loosening the plug until the oil is free of air bubbles. Assure that pipe couplings and plugs are tightened and that there are no leakages from the filter housing. The fuel oil injection pumps inject the correct amount of fuel into the combustion chamber via short high-pressure pipes and the injection valves. The pumps are driven by the camshaft via the push rods and regulated by the regulator via the link arms. All engines running on heavy fuel oil are equipped with a cleaning system for the fuel injection pumps. It is of great importance to check the control levers and fuel pump racks weekly for sticking. Tightening torques for nuts on high-pressure fuel pipes must be inside the tolerance given. Too high tightening may lead reduced flow of fuel to the cylinders, due to narrowing of the pipes. All engines running on heavy fuel oil are equipped with a cleaning system for the fuel injection pumps, in order to prevent the control rod and sleeve from getting dirty and sticky. The fuel injection pump cleaning system should always be operating when running on heavy fuel oil. After cleaning or overhaul of the fuel injection pumps, start the cleaning system before the pumps. Check the level in the diesel oil tank. The fuel oil injection valves should provide the injection of fuel oil to the combustion chambers. When operating on heavy fuel oil, the nozzles have to be cooled. This is done by the nozzle temperature control system. A nozzle should not be disassembled for inspection or changed unless the single cylinder exhaust's temperature deviates considerably from the average. Please click the graphic showing the correct behaviour of the fuel injection nozzle during injection. High exhaust temperature in one cylinder may be caused by leaking valves, incorrect injection timing, or a leaking nozzle. The problem is easily identified by switching two valves and observing if the problem follows the nozzle. The cooling medium in the nozzle temperature control system is oil. The nozzle coolant has to be circulated also when the engine is running on diesel oil. The coolant temperature must be kept within the prescribed limits. Too low temperature may cause corrosion on the nozzles. Clean the filter once a week by turning the handle on the filter housing. The heat exchanger uses high temperature jacket water for cooling. It is fitted with corrosion plugs which must be checked and be replaced in case of leakage. The nozzle coolant has to be circulated also when the engine is running on diesel oil. The coolant temperature must be kept within the prescribed limits. Too low temperature may cause corrosion on the nozzles. Click the components for further information. The governing system. Upon a start signal from the ship's auxiliary engine control system, starting air is led to the engine. The tacho relay receives a signal from a magnetic pickup on the flywheel cover, which indicates the engine's speed. When the speed exceeds 300 rpm, the tacho relay sends a signal to the speed controller, indicating that the engine is running and the starting air is shut off. The speed controller receives a speed signal from a magnetic pickup on the flywheel cover. While the engine's speed is below normal running speed, it sends signals to the actuator fitted on the flywheel end of the engine to increase engine speed. The actuator transforms the electric signals to mechanical movement, and through arms and linkages, it changes the admission of the fuel oil injection pumps. In multi-engine systems, when the engine receives normal running speed, the synchronizer starts comparing frequency, phases and voltage on the net side with the corresponding values on the generator side. When they are equal, the synchronizer closes the circuit generator breaker and the generator set is connected to the bus. The synchronizer is automatically switched off afterwards. When the circuit generator breaker is closed, the speed controller receives signals indicating the load of the engine from the sensors in the switchgear and signals showing the load of the other auxiliary engines in the vessel. If the load of the engine diverges from the wanted load compared to the other engines, the speed controller changes the signal to the actuator to change the admission on the engine. When a change in the load on the main bus occurs, the generator will be forced to increase its output. Since the engine speed is constant, determined by the frequency on the main bus, the increased load from the generator results in an automatically increased power output from the engine by increasing the admission. Click the components for further information. The electro-hydraulic actuator is fitted on the flywheel end of the engine. The actuator receives electric signals from the speed controller, which it transforms to mechanical movement. Through arms and linkages, the actuator alters the admission to the fuel injection pumps, thus regulating the output from the engine. The linkages and arms leading from the actuator to each of the fuel oil injection pumps must always work smoothly. This should be checked every day and grease added in all joints and couplings when needed. Control and safety system. The engine transmitters send signals to the alarm and monitoring system via the junction box on. These signals may be observed while the engine is running, thereby making it easier to monitor the operation of the engine. In addition to these transmitters, the engine is equipped with numerous manometers and thermometers, which should be logged at a daily basis and compared to the values observed on the alarm and monitoring system. If the signals monitored by the alarm and monitoring system are outside the preset intervals, the system will trigger an alarm. Transmitters and switches on the engine send signals to the safety system, which will result in an engine shutdown if the values are outside the preset interval. Two overspeed trips are fitted to the engine, one mechanical and one electro-pneumatic. The mechanic overspeed trip is triggered by a spring-loaded weight on the camshaft, while the electric pneumatic is triggered by an electrical signal transmitted by the tacho relay. Operation and surveillance. Learning objectives. The main objectives of this section are to make the operators able to describe components and systems which should be operating during startup, describe components and systems which should be in standby mode during startup, recognize the components to operate during startup, describe what actually happens within the system during startup, describe the critical parameters and know where to find the measuring instruments, rectifying actions in case of deviation, before starting the engine after a period of standstill shorter than 24 hours, the following routine should be performed to ensure a safe startup of the engine. If the fuel system has been disconnected, it will be necessary to expel trapped air in the system. Disconnect the high-pressure pipe between some of the fuel injection pumps.